Hello guys, this is the continuation of my study of the airfoil where we would like to do simulation of the flow around it, and we already had imported airfoil geometry into design modeler. We scaled it to 10 centimeters hard, and we also created the surface of our airfoil. So the next task will be to organize the internal volume of our simulation. First of all, to do that, I will have to create external volume of the simulation and then split this volume into more simpler volumes. The idea is that we must obtain quite simple and small volumes, then we will be able to control the quality of the mesh in every zone, especially near the airfoil, with a good precision. So I will start from generation of the volume of the flow around my airfoil. Now this volume has a C shape, and to do it I can use the tool concept surface from sketches. So I select my sketch 1 as a source to build the volume, and I will apply here. If everything is working well after clicking button generate or F5 on the keyboard, we should receive the volume. So this is the volume of simulation which we have, and inside which we will calculate the flow. The problem now, we can observe that the volume inside our simulation and inside the uh, airfoil, they cross. So we must exclude volume of the airfoil from the simulation, because we are calculating flow only around airfoil but not inside the airfoil. So to make it, I will use the tool is placed here on the create of the Boolean operation, and in the Boolean operation I'm able to choose subtract operation over here. As my target body, I choose the external volume, I apply here, and the tool body is the body which we exclude from simulation, is this body of the airfoil inside. But here we can see just two different choices. This one is external flow and this one is internal flow. So I exclude the internal flow, which can be seen here by this yellowish orange color. I apply here, and if everything is fine after clicking on generate button, we will be able to see picture like here. This is the flow in gray, which will be simulated, and inside the airfoil we have empty space. So we receive this big volume, and unfortunately right now we cannot do meshing and to go to next step, because this volume is quite complex. So I will simplify the volume. I will split it into many simple volumes, and then we will be able to control these simple volumes. To do this, I will have to create a new sketch. It will be called sketch 3, for example, or we can always rename it to another sketch. Let's say can be a split, just a split or split volumes. I recommend you to put the names to them to understand what you are doing, why you are doing. Actually, any of these operations cited in the design modeler, they can be renamed as well. So I have a split volumes sketch, and inside this sketch I will put several lines to split my big volume. I already have a point which we created corresponding to 1/4 chord, and with this point we can proceed to build our lines. So I go to make a horizontal line going in this direction. To the left it will be another horizontal line going to the right. Okay, it will be a line going to the top of my volume like this. You can observe already letter V in the middle of the line, which corresponds to vertical direction, so it will be automatically oriented to vertical direction, this line. And I will put another line going down. I do this separately, but you, if you want, you can do just one line. Here, what happened? We have some, yeah, have some point was it disappeared somewhere. We had a point here, but now I think it's gone. Oh, it's here. Okay, has to be really carefully, and if we do the automatic vertical line alignment, some lines, they, of course, they can move. To prevent movement of the line, we always can use the fixing in tool, the constraint of the fixing. In this case here, I will not use it for now, but I will try to put more precisely my line positions like this. Okay, let's go back to the airfoil, and here we need to put lines starting from the airfoil. Now it's already here, and on the trailing edge of the airfoil also a vertical line. Approximately I will put it like this, and after we can change its position. Okay, this line will have to be on the trailing edge of the airfoil. Now, since we know the size of the airfoil, it's 10 centimeters, I will just put a dimension of 10 centimeters between leading edge and this line here. To make it, I will do some trim of the line. I will cut my front line here, and I receive the point until which I have to put my dimension. So here I put a horizontal line between this and this. Okay, and it will be exactly 0.1 meter. So it's moved automatically to trailing edge of my airfoil, and now I have this size here. Also, I have to organize internal volume around my airfoil, so I will draw one circle. This circle like this one will be a size of 10 centimeters as well, equal to my chord. I will put a dimension to control it, and this is given as diameter right now. Okay, but I need radii, so I will cut some part of this circle. I will trim it from here and here, so we have a semicircle, and I will put a dimension now in the new semicircle. Now it transformed from diameter to radii, and I will put 0.1 meter as well, so it's one chord. Isn't a volume near the airfoil, we have to mesh separately to have a good accuracy near the airfoil. And also I put the horizontal line like this and like this long rectangular volumes here. They are formed for the precise simulation of the boundary layer separation from our model. I will cut also the lines which I do not need on this part. I will cut the lines which we received on the top. Okay, I will cut some lines which we have on the left, and on the bottom of the drawing here they are Okay, like this. And already with all these model, all this sketch, we can try to split our volume, our complex C-shaped volume, into a simple volumes of a small size. So I will go back to the modeling. I will try to regenerate. Everything is working fine. You can see that all green V's are here, and I will use the tool which is split. I will have to split this. Let me see, it's split edges, split surfaces, and face split here tool in the tools. Face split is working by the following way. You have to receive a target. Target to split is our big volume now, and apply, and you have to select the tool geometry. And here we have some tricks, because not always lines from sketches, they can be considered as the tools to split the geometry. So we must be really precise, and we must be sure that we can use it. To select the lines here, I use this tool here, selection filter of edges, and I will try to select all my edges for the splitting which I just have been created. We can see already one problem. The problem is that there is no edge over here, so I will make this correction. And also this line, we don't need the axis, we will not use as a tool. So one line is missing, but this is not a big problem. We just will adjust it after some modification. So we have selected just 8 lines now, and let's see if it's working. We go back to correct the line. So I will choose here the selection filter of faces, and I will see. Okay, take a look. These are splitted volumes around our airfoil. I can click on every of them, and I can see that they all are separate, and our airfoil is here in the middle. So even though if I did not select this line here, or it was not visible in the design modeler, which is also possible, that line exists but it's not visible, unfortunately, can be this error can appear, even though we have these volumes separated. So what is the strategy of the volume separation? At the end, you can look, if you are carefully looking to the geometry which we receive, every of this volume, it has 4 edges, and it has opposite edges. For example, if I take a simple geometry like this one, I zoom to it, and we will see that it has 4 edges. This upper edge here is opposite to this lower edge, and this left edge is opposite to the right edge. And the same we can tell about any of these volumes here. For example, if I select this one, I will have this lower edge, and this upper edge, and this lower edge, and this right edge. They're opposite. Having the opposite edges is very important inside the meshing, so we can use a special meshing tools, and we can solve many problems of meshing just if and when we split our complex volume into simpler 4 edge volumes. So every of this volume which I created, it has 4 edges. Again, to remember you that size of this volume, big size is 25 horde sizes, okay, and the small volume here is one horde size to every direction here, and then these big rectangulars, they are having one horde per 25 hordes, so a very long stretched rectangulars. Okay, so at this moment we are finishing study of splitting of the volume, and next study will be devoted to a meshing of this volume, and one of the ways of the meshing of these volumes for the simulation of incompressible and not viscous flow around the airfoil. And of course, after we succeed in this, we will go to meshing of viscous flows. Thank you.